Hello, welcome back to Blender Sushi Live Noding. In this episode, I'll be sharing with you this node 3 I created using geometry nodes in Blender. So it's basically forever rolling monkey head or some kind of setup that's allowing you to do this. It's actually really simple. It seems like there's a lot of nodes, but it's actually this part can be simplified. So each monkey head here have a different seed, and each different seed with kind of allowing the monkey head to rotate on the ground at different speed and different rotations, so it's more randomized. But I can just delete all of them, it's not necessary. This is what it looks like for 3 different objects. They're all using the same geometry nodes, node 3. So like I said, this is the time value that's driving the rotations or the spinning, and the secret is really the bounding box. So this node does everything else is just helping it. So this time, there's this add, basically it's like a time offset, so I'm offsetting the time using the seed value, and also I'm controlling the speed. So it's always about offset of time and multipliers to make it random. So this part really needs to be grouped. So the rest of them is like, I have a transform and rotations. Okay, so this guy is definitely rotation, doing a rotation by itself, but the rotations also being pushed by the bounding box. So it's always trying to stay on the floor, right? No matter how it's scaled or how it's being rotated, it's gonna adjust itself correctly. So that's the basic idea. So geometry nodes allowing you to do this using the bounding box. Just get the minimum and maximum of the z-axis, subtract the distance, multiply by half, and then combine it and translate it up. That's really the idea. If I simplify everything, how I started this, so I only have this monkey head. This is the original setup without any kind of seed offset or whatever. I could set it up so I could replace Susan head with something else. That's really the way this works. It's like if you have like a cone here, just use geometry nodes and just use the same one. So this should put it on the floor. Yeah, I think something like that. Just be careful with the center of points. I think that's something that I didn't consider. So if you want to randomize this, let's take a look. So basically, I have this multiplier. I have this time multiply that controls the rotations of Suzanne. Okay, I can give a different rotations. It's kind of spinning, but it's using the same value. But I can offset that if I want to. A good way is to use random float for each XYZ. So you could do it this way. So time multiply, this is the speed for the time, however, we can have it random. But let's see, this is the geometry nodes, right? And then I could use a seed and make 3 random value. The way I do it usually using another math. Just randomize this number. So now we have 3 different value coming in, and this can goes inside multiplier. And then this value can goes into combine XYZ, and this is for the rotation. So now Suzanne is like kind of breakdancing. And the bounding box will always push it up. So this part is pretty much correct. If I scale Suzanne slightly, it will still always on top of the floor. And I can scale it as well. So that's pretty cool, I think. So that's the basic idea, and this seed randomizations give you ability to make instance with different seed value. So now we have different Suzanne for each one. So that's really the basic idea. If you want to instance this, I recommend you not to use geometry nodes, although you can sort of set it up so you can have like 100 Suzanne instance doing different variations of breakdancing, which is could be an interesting idea. But you don't need to have like 100 Suzanne. Normally you have just 25 or 65 variations. Should be enough. So this guys is controlled by geometry nodes, right? I can make new collections, call it blah. Okay, hide it. Now I can try create another, create a cube, delete everything, new geometry nodes, turn this into a plane or grid. So we have a bunch of points here. We can use instance based on collections, turn off whole collections, just get blah. So now we can have maybe 64 Suzanne doing some crazy stuff there. You can also, of course, use point distribute. This also works. So Suzanne had dancing and dancing and distancing and keep on rolling. It's pretty interesting. How far can you push this? I don't know, but I think geometry nodes is pretty fast. You can see there's of course some heads is rotating the same way, but you can always rotate it here further, you know, like randomize. Our brain cannot tell if the rotation, we randomize further each of Suzanne head, so we cannot tell which one is just a copy of the others or just an instance. Okay, look at this. That's the distance between person. If they just keep everyone's apart, like a, I don't know. It's a little bit weird, but anyway, this is some dancing Suzanne head using geometry nodes, completely using geometry nodes, and you can just simply bake it. All right, so thanks again for tuning in, and I'll see you next time. Thank you. Bye.